Hello all, we are going to do 4.2, some information from 4.2. And I'm going to start by talking about the notes that I put on Google Classroom for you. The quiz you're going to take for 4.2 has a lot of almost like vocabulary, but really it's a lot of questions about how to prove a polygon is a parallelogram. So I decided to write some notes on that for you. First of all, what's a parallelogram? It's a four-sided figure with equal and parallel opposite sides. So the opposite sides are not just parallel, but they're also equal to each other. There are 6 different ways you can prove a parallelogram is or a polygon is a parallelogram. One of those is if both pairs of opposite sides are parallel. This symbol means parallel. Another is if both pairs, this means ditto, these little double marks here. Ditto means I was too lazy to write the word right above it. So number 2 is both pairs of opposite sides are congruent. So if either both pairs of opposite sides are parallel or both pairs are congruent, it's a parallelogram. Or another way you could do it is if both pairs of opposite angles are congruent. So these two are about the sides. This one's about the angles. If the pairs of opposite angles are congruent, then it is a parallelogram. Totally unrelated to pairs of opposite anything, right? Now we're on diagonals. That's down here. If you look at the diagram, the diagonals go straight across here and straight across here. If the diagonals bisect each other, and if I look at my diagram, I have 3 tick marks here, 3 hash marks here. If those hash marks match, that means this is equal to this, and that means it is being bisected. And the same here, we have 4 hash marks, another 4 hash marks. This one is also being bisected. So they're bisecting each other. If that's all I had, I could prove that this figure is a parallelogram. And then another way is if one angle, this one's a little funky, if one angle is supplementary to both consecutive angles. Okay, so let's think. If possible, try to ignore what's inside here. No, better yet, let me draw one. I'm going to draw another parallelogram because I don't want to confuse things too much. So let's talk about that one. It gets a little funny. Here we go. Let's switch to my whiteboard. It says, if I have an angle here, it said if one angle, let's say that this was 80 degrees. And if both of that angle's consecutive angles are supplementary to that one, well, consecutive means kind of like one after the other. So if I kind of work my way around this parallelogram, the angle that's consecutive to this is right here because it's just kind of after it. If that one is supplementary to that angle, and remember it said if both consecutive angles, so the other consecutive angle would be this one up here. If that one is also supplementary meaning they add up to 180 degrees, that's enough to prove this is a parallelogram. So that's what that statement is saying. If one angle, that was that 80-degree angle, is supplementary to both consecutive angles, those are the same side interior angles. And what they mean by that is, look, if these were lines and a transversal, these would be same side interiors. And I could do the same with the other. Same side interiors are supplementary when the lines are parallel. So that's enough to prove these are parallel, but we don't even have to go that far because this is saying this right there, number 5, that's enough to prove that the figure is a parallelogram. And then last, if one pair of opposite sides are parallel and congruent. Let's go to my other diagram here. Let me clean this up a little bit. If one pair, so like I said that these are parallel, what if I said they were also congruent? And let's say I didn't have these angle measurements. That alone, let me clean it up. That alone is enough to prove those are parallel and congruent. That alone will prove that is a parallelogram. Okay, so those are all the different ways you can prove it. And then I also just want to point out, I wrote, can you see the two pairs of congruent triangles? This triangle up here is congruent to this one. We could use side, side, side. We could use side, angle, side. We could use angle, side, angle for that matter. We could use a lot of different things. And the same reason this triangle over here on the left is congruent to this one on the right. When we're able to prove some of those triangles inside are congruent, and we can use those congruent parts of the triangles to prove that the figure is a parallelogram as well. So I just kind of wanted to add that in there. All right, so that's some of the information you're going to need for the quiz. Let's dive into the worksheet, the 4.2 checkup. And I'm just going to do a couple of these right now, and then we'll call it quits, and then I'll do a couple more in another video. If the video is too long, it just takes forever to download, and you guys are probably tired of watching me anyway. Here we go. Excuse me. A farmer needs to enclose a section of land in the shape of a parallelogram by using one side of the barn for one side of this enclosed section. Let's draw it. Right away, I'm like, well, it's going to look something like that, but I want to start nice and clean. So we're going to have, here's the side of my barn. I don't know why I drew it at an angle, but there it is. And, oh, excuse me. And they want to enclose a section that's going to end up being a parallelogram. And one of the sides is the side of the barn. Okay, so that's kind of what they're talking about. This right here is the barn. All right, let's read on. Helps to see it, at least for me. The barn and the side opposite the barn will both be 9 feet long. All right, the barn, this right here, the barn and the side opposite. So they're going to use right the edge of the barn. The barn is right there, and they're going to go from one edge to the other. Those are both 9 feet. That one's 9 feet also. It doesn't look like a parallelogram, but it's just a bad drawing. One of the other sides will be 7 feet long. All right? Doesn't matter which. My diagram is not very pretty, but one of the other sides is 7 feet long. Got it? Remember, it's a parallelogram. What is the length of the last side? Okay, so let's go back. We're looking for this guy right here. And what we know about parallelograms is that opposite sides are equal. So that other side must be 7 feet long. You probably didn't even need the diagram, but I feel like it helps to see it. It's got to be 7 feet. We didn't need to calculate it. We just need to have knowledge of parallelograms. I'm not going to solve 2 and 3, but I'll set up number 2, and it'll be pretty close to the same for 3. We're solving for x, and remember we just said opposite sides of parallelograms are equal. So that means this side is equal to that side. And it says solve for x. You have your equation. Just go ahead and solve for x. I won't solve it for you. Number 3 is very, very similar to number 2. All right. Number 4 and 5, a tiny bit more difficult. 5 in particular is more difficult. Let's look at 4 again. This is equal to that. At the top of the worksheet, it says these are all parallelograms. If they weren't, we didn't know that, we wouldn't be able to solve it. But if we know it's a parallelogram, we're going to set them equal. So that means 2x plus 50 is equal to 4x plus 20. The reason I know, because it's a parallelogram and opposite sides of a parallelogram are equal. And by the way, these diagonals, they're not there to help me solve the problem. They might be there to confuse me, but we won't be confused. We're trying to find the length of NO, so we need to know how long this is. Well, if I find x, I could plug in x and then calculate to see how long NO is. So that's the goal. In fact, that's all I'm going to say. I'm going to let you solve for x. Maybe I'll do it. Why not? Get x on one side. I just can't help myself. Subtract 2x. That'll get all the x stuff on one side, giving me 2x here. And then let's move all the other stuff over bit by bit. We get 2x on the right, 30 on the left. Let's get rid of that 2 by dividing it out, and we get x value 15. That's not our answer, though. If this is multiple choice, there's a good chance we're going to grab that as our answer. Be careful and read it. We have to plug in that x value. So I'm going to work right on here. We had 4 times x plus 20 is NO, so we'll take that x value. I will let you finish the problem. Okay, leave myself some space. Finish it off. You're going to get NO is whatever you end up with here. PEMDAS. Sorry, I'm sniffly from my sneeze. Number 5. Number 5 gets a little more tricky. We really just have to think about all the different things that we know with parallelograms. LB, they labeled it here as 6. And LN, this whole thing is 2x plus 5. 2x plus 5. Let's zoom in. This one's getting tricky. We don't want to be fooled here. All right, what do we know about parallelograms and their diagonals? Because they've given me some information that involves one of the diagonals. And if this is a parallelogram, we know the diagonals are bisected. That means they are split into 2 equal parts, which means if this is 6, this is also 6. But more importantly, if those are both 6, the whole thing is 12. It's getting kind of messy in here. The whole thing is 12. But time out. It's 12, but it's also 2x plus 5. If ln is 12 and ln is also 2x plus 5, they must be equal to each other because they're both equal to ln. Meaning 12 must be equal to 2x plus 5. I kind of jumped into the problem without reading all of it. It wants me to find x. Oh, I thought it was going to ask me for something more. Nope, we're good. Find x. Yeah, we're good to go. I'm going to let you solve it, and we'll call it good. You can finish the problems. I'm going to do another video for some more problems on this 4.2 worksheet, but for now, let's call that good. Have a great day.